Assalamualaikum. My name is Muhammad WABEEL and introducing my team member which are ALIF, NADZMEEN and IRFAN. Today, we would like to talk about the REDBUS database and its significance to the REDBUS website. REDBUS is an online platform that allows users to book intercity bus tickets, and it was launched in 2006. Over the years, REDBUS has grown into a major player in the online travel industry, operating in over 50 countries and partnering with thousands of bus operators. The success of REDBUS can be attributed to its use of advanced technology, including the REDBUS database, which plays a crucial role in storing and managing data for the website. However, despite its success, there has been some difficulties with the REDBUS database. Firstly, it can be challenging to total up the sale of the company for each month due to the database not effectively tracking the sales data. And the second one is, users have trouble to finding the correct schedule and route information, as the database may not be updated frequently enough or may contain incorrect information. And last but not least, it is difficult to identify all ticket orders for one customer, as the database does not have a system in place to effectively track the ticket order of individual customers. That's where our project comes in. The purpose of this project is to address this problem in the REDBUS database and improve its accuracy, efficiency, and overall user experience. To achieve this, we plan to construct an entity relation diagram, which is ERD, to model the relationship between entities in the database. We will address the difficulty in totaling sales by designing a database table for tracking sales data, and address the difficulty in finding correct schedule and routes by designing a database table for storing bus schedules and routes. Finally, we will address the difficulty in identifying all tickets ordered for a customer by designing a database table for storing customer information. We will use data definition language, which is DDL, to create the database table and define their structure, which will give us the opportunity to apply database design and SQL concept to a real-world scenario. By improving the REDBUS database, we aim to enhance the overall user experience of the REDBUS website. Users will be able to see how much money the company made each month, find the correct bus schedule and route easily, and have access to up-to-date and correct information. Additionally, we will be able to keep track of all the tickets ordered for one customer, making it easier for both REDBUS and its customer. I think that's all from me. I will pass the next slide to IRFAN.
Thank you, WABEEL LUQMAN, for the introduction. In the chapter 2, we'll be talking about the conceptual design. 2.1. The methodology used in this project will follow the database life cycle, also known as DBLC. Methodology. The DBLC consists of 5 phases: requirement analysis, logical design, database design, implementation, and maintenance. This methodology will be used to design, implement, and maintain the REDBUS database. The first step in the DBLC methodology is the requirement analysis phase. This phase will involve gathering information about the needs and requirements of the REDBUS website and its user. This information will be used to identify the problem with the current REDBUS database and determine what changes next to be made to address this problem. The requirement analysis phase will involve reviewing the current REDBUS database to identify areas for improvement, as well as conducting survey and focus group with REDBUS users to gather their input on what changes they would like to see. The next phase in the DBLC methodology is the logical design phase. This phase will involve creating a conceptual design of the REDBUS database, including the entity relationship diagram, also known as ERD. The ERD will be used to model the relationship between different entities in the database users, such as bus routes, booking, and promotion. The ERD will help to ensure that the database is structured in a way that meets the needs of the REDBUS website and effectively address the problem that have been identified. The third phase in the DBLC methodology is the database design. This phase will involve creating a detailed design of the REDBUS database, including the data definition language, also known as DDL code. The DDL code will be used to create the database table and define their structure. The DDL will be used to specify the attribute of each table, such as the type of data stored in each field, the relationship between tables, and any constraint or rules that must be followed when inserting, updating, or deleting data. The fourth phase in the DBLC methodology is the implementation phase. This phase will involve creating a populating the REDBUS database. This will include the execution of DDL code to create the database table and the insertion of data into the database. The implementation phase will also involve the development of any necessary database query or script that will be used to retrieve information from the database and support the REDBUS website. The final phase in the DBLC methodology is the maintenance phase. This phase will involve regularly updating the REDBUS database to ensure that the information is accurate and up to date. This will involve the execution of database queries or scripts to retrieve and analyze data, as well as the insertion of new data into the database as necessary. The maintenance phase will also involve making any necessary changes to the database structure to support new features or functions of the REDBUS website. On the next slide, we'll be talking about business rule. Each customer can have many tickets, and many tickets can be owned by one customer. The second one is each ticket can have one booking, and one booking can be made for one ticket. The third one is each booking can be made by one staff member, and one staff member can make many bookings. The fourth one is each route can have many tickets, and many tickets can belong to one route. The fifth, each route can have many promotions, and many promotions can be applied to one route. The sixth, each bus can belong to one route, and one route can have many buses. The seventh, each ticket can be sold to one customer, and one customer can buy many tickets. The eighth, each staff member can have many bookings, and many bookings can be made by one staff member. The ninth, each customer can have many ratings and reviews, and one rating and reviews can belong to one customer. The 10th, each bus can have many ratings and reviews, and one rating and reviews can belong to one bus. And the final one is each ticket can be sold to one customer, and one customer can buy many tickets, resulting in many sales. The next slide will be presented the ERD form of the business rule. The next slide will be talking about the relational scheme, also known as the third normal form, or BCNF. First of all, there's customer table. In the customer table, they will have customer ID as the primary key, while the other is their attribute, such as customer name, customer email, customer phone number, and customer address. The ticket table will have the primary key as ticket ID, and the foreign key will be route ID, customer ID, and the attribute will be ticket price. On the booking table, they will have booking ID as the primary key, ticket ID and staff ID as the foreign key, and booking date and booking seat will be the attribute. On the route table, the route ID will be the primary key, bus ID will be the foreign key, route name, departure location, and arrival location will be the attribute. On the promotion table, the promotion ID will be the primary key, route ID will be the foreign key, promotion code discount amount will be the attribute. Buses table will have bus ID as the primary key, bus number, bus type, and bus capacity will be the attribute. For the rating and reviews table, rating review and reviews ID will be the primary key, customer ID and bus ID will be the foreign key, and also they will have rating and review as the attribute. For the sales table, sale ID will be the primary key, ticket ID will be the foreign key, customer ID will also be the foreign key, and also sale amount will be the attribute. Lastly, we have staff table. Staff ID will be the primary key, staff name, staff position, and staff phone number will be the attribute. Now I will pass on the data dictionary to NADZMEEN.
Next, we move on to the data dictionary.
As you can see, this data dictionary describes the structure of a database and it lists information about each column in the table, including the name of the column, data type, length, precision, scale, primary key, nullable, default, and comment. Here is the data dictionary created for this project.
Now I will talk about finding and result. For our first objective, this is our command to find total sale each month, and that is our result from that command. Next, our command for find total sales 1 month for August 2021. As you can see, the output we get from total sale for August 2021. For our second objective, this query update departure and arrival location from route table. As you can see, we change our departure location from Rawang to Sungai Petani and arrival location from Shah Alam to Kuala Lumpur using our command. For third objective, we can keep track for all the ticket order from one customer. Using our command, we can keep track our customer order that make from Ariana. Now I will talk about other command that cover all chapter. First, retrieve data from the customer table and display the customer name and the customer email column based on our command. So that is our command. Next, from our command, we can retrieve data from the customer table and sort the result in descending order based on the customer name and column. For the third command, we can retrieve data from the customer table and display the customer name and the length of the customer name in a new column called name length. Next, using our command, we can retrieve data from the customer table and display the customer name and a new column formatted phone that show the customer phone number in a conversion function. Fourth, using our command, we can retrieve data from both the customer and ticket table, combining the data based on the command customer ID column. Next, by using our command, retrieve the customer name from the customer table for customer who have purchased ticket with a price greater than 100 ringgit. Next, by using our command, we can get the price ticket after the promotion, as shown below. Next, by using our command, we can get average ticket price for all ticket and total number of booking made. Next, by using our command, we retrieve total sales amount for each customer in descending order. To get all booking made by staff with staff ID equal to 1 and the average rating for all bus, we use this command to get the result as you can see. Next, the average rating for each bus ordered by bus ID, we can get the detail by using our command to perform the question. Next, we can use this command to find all review made by customer ID 117 and all route with departure location from Ampang. Next, we can use this command to get all promotion with discount amount greater than 10%. This shows as below. To find the ticket ID and sales amount for all sales, we can use this command and it shows as below. For the last command, to retrieve ticket price using conversion function, we can use this command and it performs as shown in the table.
In conclusion, the REDBUS database project aims to address several critical issues identified in the REDBUS database and improve the overall user experience of the REDBUS website. The REDBUS website is an online platform for booking intercity bus tickets and has become a major player in the online travel industry. The project will start by constructing an entity relationship diagram (ERD) to model the relationships between different entities in the REDBUS database, such as customers, buses, routes, bookings, and promotion. the ERD will help ensure that the database is structured in a way that meets the needs of the REDBUS website and effectively address the identified problem. One of the major issues that the project aims to address is the difficulty in totaling up the sales of the company for each month. To resolve the issue, a database table specifically for tracking sales data will be designed, linked to the other table in the database to store all relevant information in a centralized location. This will provide a comprehensive and accurate representation of the company's monthly sales, making it easier to make informed business decisions. Another issue that the project aims to address is the difficulty that users face in finding the correct routes. To resolve this, a database table specifically for storing bus schedule and routes will be designed, linked to other table in the database to ensure that the information is up to date and accurate. This will provide a convenient and efficient service to users and improve the overall customer's experience of the REDBUS website. Finally, the project will address the issue of difficulty in identifying all ticket orders for one customer. To resolve this, a database table specifically for storing customer information will be designed, linked to other tables in the database to ensure that all relevant information about a customer's ticket orders can be easily retrieved. This will improve the overall user experience and make it easier for customers to manage their booking and track their ticket orders. The project will make use of data definition language (DDL) to create the database table and define their structure. The DDL will specify the attributes of each table, such as the type of data stored in each field, the relationship between tables, and any constraint or rule that must be followed when inserting, updating, or deleting data. In summary, this project provides a unique opportunity to apply the concept of database design and SQL to a real-world scenario. The project aims to improve the efficiency, accuracy, and overall customer experience of the REDBUS website by effectively managing the data stored in the REDBUS database. The successful completion of this project will lead to a better understanding of database design and SQL and help to establish the student as a top performing student in the field.